Hello everyone, I am Suraj and I will be explaining asymptotic notation. Asymptotic notations are the mathematical notations used for the analysis of performance of algorithms based on the size of its input. So there are three ways to represent asymptotic input. One is called big O, that represents the upper bound. The second is called big omega, that represents the lower bound. And the third is theta, which represents the average bound. So to know what these bounds are, let us take an example of an array of 5 elements. If we perform the linear search algorithm on this, and we have to find a key element. If we find a key element in the first index, that is the 0th index, it is called the lower bound. If we find the key element in the last index of the array, it is called the upper bound. And if you find the key element of the array in the middle, it is called the average bound. So we'll see big O notation. The definition for big O notation: the function f of n is equal to big O of g of n. If there exists positive constant c and c in n0, such that f of n is less than or equal to c into g of n, for all n is greater than or equal to n0. So we have a function here, f of n, which is equal to big O of g of n, which can be represented as f of n is less than or equal to c into g of n, where c is a constant. We have an example here. F of n is equal to 2n plus 3. We take it 2n plus 3 is less than or equal to 10 into n. Here 10 is our constant, n is the value of g of n, and 2n plus 3 is our f of n. So if we substitute the value of 1 in place of n in this equation, we get phi is less than or equal to 10. So which satisfies this. So we can say that g of n, here our g of n is n. So we know g of n, f of n is equal to big O of g of n. And since g of n is n, we can say f of n is equal to big O of n. And here we have the graph of big O. So this represents the time, the y-axis, and the x-axis represents the number of inputs. So f of n, it varies with time and the number of inputs, while c into g of n, that is this value over here, this will remain constant after a certain amount of inputs, after a certain amount of time, it will remain constant. So we can see here, again, f of n is equal to big O of g of n, f of n is equal to c into g of n, where c is greater than 0 and n is greater than or equal to k. K is this point where the f of n and c into g of n meets, and k is also greater than or equal to 0.
Myself Tejas H.S. I am continuing with the big omega. The definition goes like this: the function f of n is equal to omega of g of n for every positive constant c and c naught, such that f of n is greater than or equal to c into g of n for every n greater than or equal to n naught. The example we have taken is f of n is equal to 2n plus 3. Here 2n plus 3 is greater than or equal to 1 is there, 1 is the constant c. So we can conclude that f of n is equal to omega of n. The graph for this is this. The function f of n varies randomly with the input and time, but the c into g of n increases slowly with input and time.
Hello guys, I am Pramod. In this video, we will learn about asymptotic notation. There are 3 types in this notation. One is big O notation, and the second is omega notation, and third one is theta notation. This is going to be third one, theta notation. So what is theta? Theta is there is the upper and lower bound runtime of algorithm. This is denoted by theta, and this is the theta graph. C2 g of n and f of n, C1 g of C1 into g of n. theta rotation, and let's discuss about example for this theta rotation. C1 is 1, C1 is equal to 1, and C2 is equal to 4. Let's take equation C1 into G of n less than or equal to f of n less than or equal to C2 G of n. Let's C1 is 1 into G of n is equal to 1. N is always 1 less than or equal to 3 into n plus 2 less than or equal to C2 value 4 into 1. Then 1 into 1 less than or equal to n value 1. So 3 into 1 plus 2 less than or equal to 4 into 1 4. And the next step 1 value 1 same less than or equal to 3 into 1 3 plus 2 answer is 5. Okay. Example 1 is not satisfied. The condition is false. Let's go to the second example. Let's take G of n is equal to 2 and n is equal to 2. G of n is equal to 2. After this 2, C1 1 G of n 2 is there are equal to 3 into n value 2 is there are equal to C of 2 value 4 and G of n is 2. Then the answer is 1 into 2 2, 3 into 2 6 plus 2 8 and the 4 into 2 8. This is the this condition is satisfied and the condition is true. Condition is true. This is the theta explanation of asymptotic notation. Thank you.